Hey, welcome guys. So this video, let's just do a simple exercise of the exact sequence. Yeah. So after that, if we talk about show 5 lemma, then it should be easy. Okay, so this simple exercise tell you that yeah. So basically, you can change into abelian group or vector space if you are not familiar with the commutative ring. Okay, so give a exact sequence that you have x, z, y, and we know that kernel p, x, z, y, and ip, and we have kernel p isomorphic to x. If you have this exact sequence, then co-kernel I will be y, isomorphic to y. Okay, so remember exact sequence means that the image same as kernel, right? So I and j. So this means that the image of I is the same as kernel J. So we basically, and another important theorem is that if you have a map from A to B F, then the first isomorphism theorem tells you that A modulo kernel F isomorphic to image F. Okay, so let's see the first one. Let's quickly see the first one. Yeah, so this exercise are very simple that you guys should. If you want to try to learn it carefully and understand by yourself, you guys should try by yourself, right? This is very easy exercise. Okay, so the proof is very easy. So let's see. So what we just write down everything we have, right? So we have image, we have kernel 0. Oh, sorry, the image 0 equals to, right? We see this equals to kernel I, and then we have the x modulo or kernel I will isomorphic to image z. Okay, right? And then we also had the image I, sorry, not image I, right? Image I isomorphic to image I is the same as kernel p, right? So combine these two, you get x modulo kernel I isomorphic to kernel p. Right, but kernel I is 0, right? Because image 0 is 0. So modulo 0, which is x. So x is isomorphic to kernel p. Okay. Okay, then this is x, z, p, y, x, z, y, and ip. We have a co-kernel I isomorphic to y. So x, z, y, ip, and then we have a co-kernel. Let's see. Right, so we have we want to prove that the co-kernel I isomorphic to y. So we have to prove this. Okay, so let's see. By the way, what is co-kernel, right? So if you have A to B F, that you guys should know that the co-kernel of F means that B, right, modulo image A. This is called a co-kernel. Okay, so yeah, let me just make the thing clear so that we will should be here. Let's just okay. So let's see. So from here we have the image I equals to kernel p, and the x modulo kernel I isomorphic to image I, and we have so this is basically this, right? And then we have another which is this. So we have the z modulo kernel p will isomorphic to image p. Right, and but we know that this is exact, so image p is onto, right? It's surjective, so it means you will cover all the y. So z modulo kernel p should give you y, okay? And let's see. So we have x, we have image I equals to kernel p, right? So which this can write as z modulo image I isomorphic to y, and where kernel I is so let's see. So our goal is to prove cokernel I is isomorphic to Y. So Z module image I, right? So here Z module image I, which is just cokernel I, right, by definition. Yeah, so actually we only need this section and we don't need this. Okay, so yeah, these two these are very simple exercise that you guys should check, that you can write down by definition. Okay, and we can prove the 5's lemma, and next time we will prove more difficult